If you want to take over a computer server, you need to find a remote code execution flaw. These are the rarest, most destructive bugs in software, and exploit brokers routinely pay human researchers up to $500,000 to find them. But this past week, a researcher at Searchlight Cyber handed that exact job to OpenAI's GPT 5.6 model. It ran autonomously, hunting through code, and found a $500,000 vulnerability for about $25 in computing time. The target was WordPress, a platform that powers over 500 million websites. The flaw was so severe it triggered an emergency force-installed patch across the internet on July 17th. Work that used to require weeks of intense focus from elite, highly paid security experts can now be executed by a machine for pocket change. This cost collapse extends directly into building software. Developers are now using a technique called agent swarms. Instead of paying a premium artificial intelligence to write every line of code, a single, expensive smart model acts as the project planner and then delegates the actual typing and logic to a fleet of cheap, fast models. This structural cost comparison chart shows the result of a recent internal test rebuilding the SQLite database engine. Using a single premium model for the entire job cost over $10,500. The swarm approach completed the identical task while avoiding thousands of coding conflicts for just over $1,300. We see this exact automation applied to highly technical writing. A new study analyzing the preprint server arXiv found that roughly a third of recent scientific papers show clear signs of AI-generated text. In computer science, that number spikes to 65%. Finding security flaws, rebuilding complex databases, and writing academic literature all share the same trajectory. Specialized knowledge generation is steadily moving from a premium human service to a widely available, highly commoditized utility. That collapsing cost has triggered a fierce policy fight. The United States largely relies on a closed system, where companies rent access to their models behind a subscription paywall. China is taking the exact opposite approach, releasing the actual files for their most powerful models so anyone can download and run them for free. The U.S. government views the unrestricted distribution of this technology as a severe risk. Regulators are reportedly weighing sweeping executive orders and entity list trade designations designed to ban American use of these Chinese models outright. Meanwhile, at the highest levels of the Chinese state, leadership is actively encouraging open source development. Just days after official calls to support the open ecosystem, tech giants like Alibaba immediately released massive, multi-trillion parameter models to the global public. This timeline chart tracks closed American systems versus open Chinese equivalents over the last 2 years. The data shows the capability gap rapidly collapsing. The delay between a proprietary U.S. model and a free overseas equivalent is now just 4 to 7 months. When one competitor is actively giving away frontier-level intelligence for free, it destroys the ability of proprietary labs to maintain a lasting competitive advantage based purely on how smart their software is. Locking down digital tools to protect national security sounds entirely logical until those restrictions hit the people tasked with actually defending the network. During a recent major breach response at the AI repository Hugging Face, American cybersecurity defenders found themselves barred from accessing certain domestic frontier models. To analyze the threat in real time, those defenders reportedly had to rely on a freely downloadable Chinese model, GLM 5.2. Teams are comparing the output of these open tools directly against paid alternatives. Analysts estimate that completing a finished task using a top-tier proprietary system can cost roughly 3 times as much as an open-weight competitor. This creates a severe structural weakness for lease-based tech companies. If raw reasoning capability is highly accessible and virtually free everywhere else, trying to charge developers a steep premium simply to access an interface will not survive long-term market pressure. Because models are getting smaller and vastly more efficient, the software no longer needs a massive data center to function. The connection to the cloud is being entirely severed. NVIDIA recently released a system called Cosmos 3 Edge. It is a compact 4 billion parameter world model designed to live directly inside a piece of hardware. It allows a machine to observe its surroundings, reason about physics, and execute mechanical actions 15 times a second completely offline. Bypassing the trip to a remote server eliminates network lag, which is critical for industrial robotics making split-second physical movements. It also keeps all factory and healthcare sensor data strictly on the local device, solving enormous privacy and compliance hurdles. Intelligence is shifting from an expensive service you subscribe to into a cheap, standard part you install directly into a mechanical body, much like a motor or a battery. If the software itself is rapidly becoming a commodity, the real economic value in this industry is migrating downward into the physical plumbing that makes the entire system possible. The companies poised to survive this cost collapse are the ones that actually own the underlying hardware. Tech giants like Meta and Alibaba are insulating themselves by owning their own server farms, effectively transforming wildly fluctuating cloud rental bills into stable, fixed physical assets. But silicon chips are only part of the equation. The absolute hard limit on global AI expansion is the sheer volume of electricity required to push data through those chips. Training a frontier model and then serving billions of queries a day requires power grids operating at an industrial scale, continuously feeding gigawatts of energy into cooling systems and processors around the clock. When the ability to write code, discover security flaws, and parse data becomes effectively free, the competition for the future is no longer about who can build the smartest algorithm. It is a harsh, physical race to see who can secure the land, lay the fiber lines, and own the power plants required to keep the machines running.